Hey, hi everyone, myself Swarnabha and I am the developer relations at DeFiChain Labs, and today I welcome you all to the workshop Building Your First App with DeFiChain. I'm based out of India and I manage all the partnership side, all the community and tech related issues and all the DevRel activities in DeFiChain Labs. And today in this workshop we will learn uh, how to build a dApp using our EVM compatible layer of DeFiChain, which is MetaChain layer. I will show you step by step how I created a simple front end, how I created a back end of smart contract and other things, and then you will be able to create a simple dApp using a MetaChain layer after this workshop, and it will be working. If you have any doubt, feel free to go to the GitHub of this code repo which I have already posted, so that you can get the knowledge of the code and how it is working, and it will be better to understand. So yes, let's get started. So DeFiChain is bringing to bridge the gap in Web3 interoperability, where we are working to bridge the gap between all the ecosystem working in different parallels and bring them in unification. If you ask me why DeFi or decentralized finance is necessary, because we have seen in traditional finance there is very high transaction cost and the clearing and settlements can take a lot of days, and we also know the lack of transparency is always there, and uh, we know sometimes there is operations very halted and limited. But in decentralized finance or DeFi, we use trust minimized software where the power is not in control with any one entity or any one person, but it is with all the person equally. So this is why DeFi plays a very crucial role, where you have everyone have equal power, and the transaction costs are also very less, which actually is still being getting optimized with each work going on in the space. And as discussed, you have the full transparency with you can check the records in the blockchain, and obviously it's accessible 24/7, and yes, it's speedy and more than the traditional finance. What bridging the gap in Web3 interoperability means is we are bringing all the different ecosystem like Bitcoin, Ethereum, Solana and other ecosystem to work together and bring all the ecosystem and their utility to work together and perform the optimizations. What DeFiChain at a glance is, it's a native layer built on top of Bitcoin with an expansion of EVM layer on which we will be building our dApp. We are built on proof of stake consensus mechanism, which is a very renowned mechanism. dApps can operate both on Ethereum and Bitcoin environment, where which is discussed in the later part of this presentation, and we have the UTXO and EVM support, making it effortless to interface with majority of the blockchains of the world. Cross-chain sharding, which is like the native interoperability across Bitcoin and Ethereum. So DeFiChain's EVM layer can run independently, and there is no need for manual bridging to move cross-chain. You can build dApps across Bitcoin and Ethereum and many more to come as we move forward. The biggest plus point is you can build once your contract once, and you can deploy it twice same time at Bitcoin system and the Ethereum EVM system both. This is the best part about the ecosystem we are working towards, where you don't need to work two times on different system like Bitcoin and then EVM and then compile and then again go back. So you can just take one build one and then you can deploy twice. The properties of DeFiChain is it's non-Turing, which means the chances of smart contract hacks gets reduced significantly less. As discussed, yes, proof of stake is the consensus mechanism which we are using. We have a high throughput and currently over 2400 transactions per second, and at last we are immutable through block anchoring to Bitcoin. If you ask me why again a chain or why again an ecosystem or why DeFi chain, So you can build once and deploy on Ethereum and Bitcoin. It saves a lot of time for the developers and resources as well. The dApp deployment and development simplifies a lot with UTXO and EVM compatibility. The maximize reach is reached because we are now targeting both the ecosystem. The benefits of DeFi chain lies in the throughput, which is unparalleled high transaction development. It is very easy to work with variety of dApps on one chain, and immutability, which is anchoring through to the Bitcoin blockchain. And yeah, now the most important part, the DeFi MetaChain or MetaChain layer, which is the EVM compatible layer of DeFi chain. It's a layer 2 EVM compatible that will build on top of native DeFi chain, making it EVM compatible. EVM compatible basically works, it can work similar like Ethereum chain, and it's more scalable and it's more useful and more utility serving. So this is the major thing, and now we will, when I deep dive into the code and the dApp development, it will make you more sense why it's used and how it's used. So our goal in DeFi chain is to increase the utility of DeFi, and yes, grow the community around MetaChain layer, the EVM compatible layer, DeFi chain as well, and then grow more as an ecosystem. If you have any doubt or any you want to be the part of the community, feel free to join to the communities by scanning our QR code, and then you can be part of the Telegram where you can ask questions, raise your concerns or anything else. So yeah, let's get now started to our dApp development, which we are doing in any, you can do it in any code software like VS Code, JetBrains IDE or anything. So I am using here WebStorm by JetBrains. So let's get started. So I have built an escrow app, and for that I have created a blog as well, where it will be easier to understand in the future for you to basically go through all the things and why it is there, and all the other aspects of the dApp. So if I open the app blog and explain you, so basically the background of this is that escrow is built for when, if you are about, I have basically built an escrow service, which is basically built for when a client wants to hire a developer to perform some work. Prior to starting the work, the developer wants to know that the fund for his work have been allocated, because sometime it may happen the developer performs his work and the client takes the work and does not give the money. So as a developer, to secure your funds for the work, once the fund for his work have been allocated, the developer wants the fund to be released when the work is finished. So here your funds will be kept at a place and it will be not released until the work has been done as per the requirements and has been satisfied by the client. This way both the parties are safe, the client and the developer, and this will be done when the client approve the work. So the client will only approve the work when it's satisfied as per the requirements. So I have made this project in two folders: escrow web, which is the front end, which is a very simple UI. You will see I've not done any much work on the UI or the interface, just a simple UI showing the necessary part of the work and interacting. And the hard hat is the folder where all the smart contract related things are there. So for this I am using Solidity. So if you are aware about Solidity, then well and good. Otherwise there are lots of resources where you can learn about Solidity. To set up the project, you just need to run this command npx hardhat, which will set you up a hardhat project. If you ask what is hardhat, hardhat is basically a Ethereum development framework where you can do all the things like testing, development, and all the other things. It makes it easier because they have already all the templates available for JavaScript, for TypeScript, and all other functionalities. So it makes development very easy. So you can deploy, test, work, and check all things here only. So I'm using here hard hat, you can see to set up, you just need to run this command and it will create all the TypeScript project template, which will contain a folder contract containing all the contract artifacts, which is basically the things used in the contract, like I will discuss it in later. And yes, all the other uh, all the other interface of contract. So yeah, and then the test folder. So this is just a simple fold, you have just written the test. So yeah, and then you will add open zipline for contracts. If I go now, I have just one contract, which is escrow.solidity, which contains all the logic for the contract and the work and the things which we need. If you ask me what is escrow factory, I will describe it, why I used it. But if you don't use it, then also fine. But here we will be discussing some hacks, or let's say some tricks, where you can save or optimize your dApp through various methods. So yeah, that comes a bit later. So escrow is the single contract where I've added all the logic and all the functionalities which will be used in our dApp. So in this, I have used open zipline contract like safe ERC20 and implementation or of ERC20. So if you ask me why I've used it, so you can write this contract by your own and then import it, but open zipline has done it for you, where if you go to open zipline docs, and you can see all the contracts are already written and deployed, and these contracts are something which are not gonna change. These are the static contract. So instead of writing them and then importing, we just use open zipline. It's a great library and it contains all the contracts which is useful for us. So if you go to the contracts, and if you see the ERC20, here you will get all the contracts, and with everything you can just import it. So yeah, so if you see, we have used IERC20, and we just if you see, they have already implemented it here. So this is why we have used it, because it makes our dApp deployment fast and easy. And then you can just go down, and now I will go into the contracts, where I have written the contract, why it is there. So first we will create a structure of the contract, which and with the import from the open zipline, which I have already discussed. Why we have used escrow factory, because this is a very famous method to save gas fees in our dApps. So many projects use a factory contract of the main contract to basically initialize and instantiate the contract so instead of doing all at one place, I have segregated into two places, escrow factory and escrow, where escrow factory is just used to initiate the contract, and it saves a significant amount of gas. So it gives us basically a way to deploy the contract from the front end in a gas efficient way. So if you see, we have this contract, and this is the structure of the contract. So here, this is the contract, and as discussed, we need client, talent, and resolver. Why resolver is required? So resolver is the mediator between client and talent. It will basically check if client has approved or not, or talent has done the work or not. Here talent is the developer. So there are basically four functions which we'll be using. Sorry, confirm, refund, and deposit. So confirm function is when it will be using all the things, and then refund and deposit. So yeah, this is the basic structure. We have just used like mapping for the confirmed, and then release or refund, basically managing the state. And then now we want to set the address for client, talent, and resolver. So this is where the initialize function comes in, and it's similar to a constructor for an initialize contract. So here if you see the initialize function, which is here in the factory, which basically initialize your function, initialize your contract, and then it gives a start, and it saves a significant amount of gas. So the escrow contract basically contains three functions: deposit, release, refund. So each of this function has two variants, one for ERC20 and ETH. You can use one as well, and now as discussed I will use only ERC20. So the deposit function takes few parameters. First is the token address and the amount, so basically the amount which will be deposited by the client, the release amount to be sent to the developer or the talent when immediately when depositing, and a note saying any message if required. So here is the deposit function, which is address, to, token, amount, and note, as we discussed. This is an event. Same with refund, address, from, to, token, amount, and note. Yeah, and here we have initialized the contract, as you can see, and this is basically before writing the test. You can just create a test token to deposit the contract. Here I have created the test token basically to check if the contract is working properly or not. So tests are very necessary to cover the dApp with all the edge cases necessary. So I will now go to Remix and show you if our contract is getting deployed or not. But first, your dApp, your MetaMask should be having the DeFiChain testnet. You can do it the MetaChain testnet. So you can install it from Chainlist. We have already integrated our network to Chainlist, so where you can go and just with one click you can add the network to MetaMask. So here if you search MetaChain and include testnet as well, as we are doing it on the testnet, so it will give you the list from where you can just get it. So meanwhile, if I go to the contract, I have already copy pasted it here. So if we search DeFiChain, yeah, this is the testnet, DeFiChain EVM network or the MetaChain layer. You can just add it to MetaMask, and if you want to have faucet, as you can see, I already have some faucet in my wallet. So that is you can also get. So if you search DeFiChain faucet, you can go here, and then as we are working on testnet, you just go to testnet faucet and you just paste your address over here, and then you enter the captcha, and then you can request 100 DFI. So you can get within 6 hours you get every 100 DFI. So this is enough for the dApp development. So here I have already configured, and if I compile the smart contract, you can see it successfully get compiled without any error. Now you go to the deploy part. So you go to MetaMask provider for the network, and it automatically catches the network, and you can just deploy here, and if it asks for confirm, and yeah, you can just deploy it easily. We already have our own explorer where you can go and check your transaction. Only thing you need to keep in mind is we have 3 mainnet, testnet, and Changi. You need to go testnet and then add your transaction hash. So yeah, so this is about deploying, and this is the initialized contract. It basically checks if the required client is all the other things, like for example, yeah. So you can just get my test script from the GitHub. It's nothing, just a simple TypeScript script having just basic test. So yeah, the release function is similar to deposit, also accepts a token address, amount, and note. So first we check if the sender is the client. If it is the case, then if we release the fund immediately. If we calculate the amount to send the resolver as well. So yeah, so this is the release function as well, similar to deposit. However, if the wallet calling this function is the developer or the resolver, we only want to release the fund. So yeah, so this is the function, and you can just check the refund function as well. So refund also uses the same mechanism and transfer fund. So the escrow factory which I showed you is just a simple contract that deploys an escrow contract. Basically, escrow factory is used to deploy the escrow contract and emits an event. By using, we can clone a deployed contract. Basically, we are already deploying a contract and now cloning it and instantiate it. The reason we do that is that it's more modular and it costs less gas for us to deploy. So, and deploying the contract is done using the hard hat. As I said, with hard hat you can do anything. We already have the script here, deploy. You just need to run the script and it will deploy it automatically. So hard hat makes it very easy. Now we have seen enough of the smart contract, and now we will go to the front end. Front end is nothing, we are just making a simple UI. Basically, it has a functionality to connect the wallet, read and write contract, and deploy the contract. So for connect wallet feature, I am using a library which is known as Rainbow, and I will show you that it helps us doing the dApp development very easily. So Rainbow is a kit which has all the functionalities of integrating wallet connect to your dApp or any feature. Most of the project uses this, and it's very easy to use. With just one command you can use it in your front end. So I'm just using that. So if you see, my front end already has a contract, and you will see here the contracts are not Solidity but in JSON. Why so? Because front end is not able to understand Solidity contract in this format. Rather, when it is deployed, it will give you the JSON or the interface of contract. Basically, this Solidity contract is broken down into the JSON format with all the functionality. If you see the name, token, address, and all the things, this version is feed to the front end, which is understood by them. And I am using some components like escrow balance, the deploy, layout, and deposit. It's very simple. You can just check it from my GitHub source. Front end is something there is no end to do anything. You can just do anyhow you want. So if I show you my front end, if you type npm run dev, it will just give you on the local host, which I have already here. So if you see, this is the front end I have built, and if this is the front end I have built, and yeah, it actually takes resolver, client, and talent. I'm just making the front end very simple. It will just take three things like client, talent, and resolver. Client address, talent, and resolver the fee, and then you can create the escrow. So as you see, yes, this is the wallet connect feature which we, as discussed, implemented using the library with just one command, which is the Rainbow kit. And if you use this, as you can see, it has all the wallet possible, and it will, as we are using MetaMask here, so I will just click on MetaMask, and you can see very easily the wallet got connected, and you can now use it with all your assets on the testnet, and you can see you can copy the address, disconnect as well. So this is the wallet connect feature which we implemented, and this is done using the Rainbow kit with just one command. And as discussed, I have implemented the UI very simply and with most basic UI tools like React.js, and I have just added very less part here like client, talent, resolver, and you can just add those things which are necessary and just create an escrow. So this was all about the Escrow dApp which we made using DeFiChain network with our EVM compatible layer 2 version of our DeFiChain, which is MetaChain layer. So I hope you learned how to make and build a dApp from scratch using DeFiChain network and interact it with the UI or the front end and make more features or add more features in future. And also I hope you learned some tricks and tips to save some gas or any implementation optimization, so that can help you in featured dApp development. If you have any doubt, feel free to join our Telegram community where you can ask doubts, get your doubts resolved. You can put your any opinion or have any discussions. As a community, we would love to have you and grow more. So I hope you enjoyed this session and making dApp from the scratch using DeFiChain EVM network, which is MetaChain layer. And in future, we will be doing this more often so that you can learn more. So yes, you can join the community and take it forward. I hope you learned something from this and keep learning and keep growing. Thanks and have a nice day. Thank you.